Okay, we have a setup of a liquid in glass thermometer. So when the temperature increases, the length of the liquid column should increase. Okay, so now let's look at the data. When the flask is left in pure melting ice of 0 degrees Celsius, the liquid column is 100 mm. So when it's left in boiling water at 100 degrees Celsius, the liquid column measures 250 mm. So you can write it down. When the temperature increases from 0 degrees Celsius to 100 degrees Celsius, the liquid column changes from 100 mm to 250 mm. Okay, so now if the length of the liquid column becomes 190 mm, what is the temperature of the oil? Okay, so with this we can say that a change in 150 mm, how I come out with this 150 mm is 250 mm minus 100 mm. So a change in 150 mm of the liquid column corresponds to an increase in temperature of 100 degrees Celsius. Okay, so this is the relationship that we have here between the liquid column and temperature. So now, in order for the length of the liquid column to become 190, so 100 mm to 190 mm, this is an increase of 90 mm of liquid column. So it's equivalent to 90 divided by 150 times 100 degrees Celsius. This will give us 60 degrees Celsius change in the temperature from 0 degrees Celsius. So we can say that the temperature of the oil should be 60 degrees Celsius. Okay, which of the following increases when a liquid becomes a gas at its boiling point? Okay, let's go through the options. The average kinetic energy of the molecules increases. This is wrong, because the kinetic energy of the molecules is dependent on temperature, and during boiling the temperature is constant, so the kinetic energy has to be constant. Option B, the molecular size will not change during a change in state. It will remain the same, so this is wrong as well. And during boiling, the liquid molecules, they have to break apart from each other to form the arrangement of a gas molecules. It should look something like this. At liquid, right, the molecules, they are close together, and to become gas they have to be far apart from each other, so the molecular spacing has to increase. So this is the correct answer. And option D, the total number of molecules should remain the same, because during a change in state the mass should remain constant. So the answer should be C. Okay, the diagram shows a wave on a string with 2 points P and Q marked on the string as shown here. So the wave is moving in this direction to the right. So what will happen next to these two particles? Okay, at the next instance, the whole wave is going to be shifted to the right side, as indicated by the new wave that I'm going to draw. So in order to form the new wave that I've drawn here, this particle P here, it has to move downwards, and this particle Q here, it has to move upwards. So the answer should be Q will move upwards, D. Okay, we are shown part of a spring that is shaken from side to side to produce this wave as shown. So the distance between successive peaks, we are given that it is 0.6 meters. This is the wavelength, and the frequency is 2.5 Hertz. So with the frequency and the wavelength, we can find out what is the speed of the wave using the formula V is equal to F lambda. So that will be 2.5 times 0.6. We have 1.5 meter per second. And how long will it take for the wave to travel 3 meters along the spring? So using the DST formula, time is equal to distance divided by speed, or the velocity here. That will give us 3 divided by 1.5, we have 2 seconds. Answer C. We have a mirror that is placed under the glass block. So we are asked which diagram represents the path of a ray of light that enters this glass block through the top surface. Okay, let's look at the beginning path. We see that the light ray is entering from air to glass. So when the light ray is traveling from an optically less dense medium to an optically denser medium, the light ray must bend towards the normal. So A is correct, B is correct, C is wrong because the light ray does not bend towards the normal, and for D is also correct. Then after that, the light ray is being reflected by the mirror such that the angle of incidence is equal to the angle of reflection, and now the light ray is exiting from the glass to the air. So it's moving from an optically denser to a less dense medium. It is supposed to bend away from the normal. So now let's draw the normal. A, the light ray bends towards the normal, so it's wrong. For B, it does not bend at all, so it's wrong as well. Option D, can see that the light ray bends away from the normal, so this is the correct answer, D.